Okay, this is going to be the first part of notes for unit conversions. I've got to split this up so the videos aren't too long for you. First we're going to start with just reminding ourselves what the scientific method is. I know you learned this in biology, but just a good reminder here. First thing that we're going to start with is an observation, hypothesis, experiment kind of loop, and then from that what happens is scientists create theories. Theories are often studied and more predictions are made, more experiments are made, the theory is modified as needed. And if that theory is modified, or if that theory is studied and those predictions and those experiments come out the same all the time, then what happens is scientists put these experiments into law. So a good example of a scientific theory is the theory of evolution, because it's still being studied and there's still things being found out about it. And a good example of a scientific law is the law of conservation of mass, for example, which we will study later in this unit. So a couple of definitions that we need to remember is just a hypothesis is a testable statement, a model is an explanation of how phenomena occur and how data and events are related, and then a theory is just a broad generalization that explains a body of facts. So those are just some good reminders of definitions that we need to know in science. One of the biggest things that we're going to do in this class is conversions, and it's really important that we need to understand how these conversions are going to be made, how we're going to study them, how we're going to calculate them. So chemists make measurements to study properties of matter, and we're going to use SI units to make sure that we keep things consistent. And we're also going to be, like I said, doing a lot of conversions between many different scientific units. Commonly used equipments for liquid measurements are going to be graduated cylinders, pipettes, burettes, and volumetric flasks, and you've also used a few of these in our lab technique lab. Commonly used for mass, we're going to use the balances. For volume, we're going to use these liquid containers here. Just a reminder about a liquid volume. Remember, liquid volumes are going to be read using the meniscus, so we're going to use that little dip down part there. You should be familiar with this again because you have completed the lab technique lab already. Because this is a burette, we would read this as 21.5 mils on that burette. So hopefully you are comfortable with reading those things by now. So measurements can be made in many different units. We're going to use SI units, which is shorthand for System International, and it's just a way that all scientists can report in the correct units and in the same units no matter where they're at. SI unit examples, so anytime we're asking for SI units, for mass, for example, you're going to use the unit gram. For length, you're going to use meter, and so on and so forth. Three things that are probably a little bit new for you are temperature. Temperature is going to be measured in this thing called a Kelvin, and the only reason why we use Kelvin really is because that's the only temperature scale that doesn't go in the negatives, and that helps us with our calculations. We'll use Kelvin a lot, especially in the second semester when we study gas laws. We're going to use joules for energy. We will study that when we study specific heat, and just a little bit during this first semester, as well as quite a lot in the second semester when we deal with energy. And then the amount of substance is a mole, and we'll actually talk about what a mole is and how much that actually is in the next unit as we dive deeper into the atom. So when we're talking about length and mass and temperature and all those things, here's just an example of all of those instruments. So right here we've got our ruler, so we would measure it in length. Right here we've got our temperature thermometer here, so in SI units we would measure it in Kelvin. Here's our volumetric flask, so in SI units we would measure it in liters. Here's our stopwatch, so in SI units we would measure it in time. And then down here, all three of these are our balances per se, so we would measure that with SI units in grams. When we do conversions, obviously we've got to first talk about temperature. We're going to deal with temperature a lot here. Fahrenheit is what we're most comfortable with because we're used to seeing that in everyday life, but we're going to use Celsius and Kelvin way more. You do not need to memorize the Fahrenheit. You do not need to memorize the Fahrenheit equation, but you do need to know the Kelvin to Celsius equation. So if I'm trying to get from Celsius to Kelvin, I add 273. If I'm trying to get to Celsius from Kelvin, I subtract 273. So that's pretty simple, and you do need to remember that. The Fahrenheit one will give you. You do not need to memorize that one, but you do need to know how to use it. So let's practice here. if it was 35 degrees Celsius, would you want to go skiing or swimming? So the first thing that we want to do is we're saying what is the temperature in Fahrenheit, so we want to just identify our equation. Fahrenheit would be 1.8 times degrees Celsius plus 32. When we do that, we'll just plug in our degrees Celsius and go ahead and get that that's 95 degrees Fahrenheit. So I definitely would want to go swimming there. In Kelvin, what you would do is take that, set it up, and add 273 to the degrees Celsius, and that would give you 308 Kelvin. So there's just a really simple example of temperature conversions with Kelvin and Fahrenheit. Some subunits that we'll talk about here. We will deal mostly with our base units here, as well as deci, centi, and milli. But it's important to know all of these base units, and it's important to know the breakdowns in all of that. You don't have this section, and so it might be worth pausing the video here and filling that in just so you're comfortable with the information given in this slide. Alright, so metric conversions using the scale here. This is a really nice acronym or little saying here that will help us remember that King Henry died by drinking chocolate milk, and it's just in order of how those values go, so kilo, hecto, deco, base, deci, centi, milli. And so if I were to fill that in on the number line here, here's kilo, hecto, deca. Our base units here, and notice those are all of our SI units too, so that's helpful. Deci, centi, and then milli. So how do I use this number line to help me with our conversion units? The first thing that you want to do, like let's say for example, I want to figure out how many grams are in kilograms. The first thing I want to do is figure out what's bigger, grams or kilograms. And I know, in this case, that kilograms are bigger, so I'm going to place a 1 right here on the number line. So I'm going to place a 1 on the number line. And then what I'm going to do is I'm going to jump values, I'm going to jump over to where the gram is. When I make those jumps, I'm going to put in zeros, and so those jumps represent zeros, so I know that for each jump there's a 0 there, and that for every kilogram, for every 1 kilogram, there are 1,000 grams. So that's kind of a little hint in terms of how to use that metric conversion scale here. So why do we need to make conversions? We're going to use a lot of different units, and we're going to use a lot of smaller units, so it's important that we're able to put things into perspective in terms of how we understand it. And we want to have 3 things whenever we're dealing with conversions. So we want to make sure we know where we're starting, so we need to know what's given to us in the problem. We want to make sure we know where we're finishing, i.e. what units do we need to end with, and then we want to make sure we know the conversion factor that's going to get us there. So we want to identify like the jumps or the changes that I have to make in the units in order to get to where I'm supposed to end to. So in this example here, the first thing I know I'm starting with right here, I'm starting with 2.1 meters, and I know I want to end with centimeters, and I know that I have a conversion unit. I know I can go from meters to centimeters. So the first thing that we want to do is we always want to set up what we know in this upper left-hand corner of the T-chart, and we always want to make sure that when we set that up that we've got our units in there as well. So units are always really, really important. Even if it's like this example right here is really simple, I know you could probably just do it in your head, but this is like training wheels. It's important that you understand how this is set up, because we're going to be dealing with some really big numbers, some really small numbers that you're not going to be able to calculate in your head. So the other thing here that we notice is anytime I start, so what I want to do is make sure that my units right here in this kitty corner box, I should say, match each other, because that's the only way algebraically that we're going to get these things to cross out. So those 2 units must always match in order for T-charts to work. And then the next thing that you ask yourself is, okay, so I have meters down here, can I go from meters to centimeters? And yes, you can, because you have that conversion unit right here, which is 1 meter equals 100 centimeters. So you're going to fill in your values, 1 meter equals 100 centimeters. Then what you're going to do is, so that's your conversion factor, and then what you're going to do is, using algebra, you know that you can cross out the meters right there, so that you're left in centimeters, which is good because that's exactly what my question is asking for. And then you're going to multiply anything that goes across the top, and you're going to divide by anything that's on the bottom. And I realize right now that there's a 1 on the bottom, but that's not always going to be the case, so that's why I like to always put that rule in there right at the very beginning when you're learning how to do this. So once I do that, I get my answer as 210 centimeters. So then what we want to do is understand also if I have multiple values either on the top or on the bottom, we want to make sure that we multiply everything first across and then divide so that we don't mess up our order of operations in our calculators. So then what we want to do in this question right here, so we know this is what we're starting with, here's what we want to end with, and we know our conversion unit, so we're always going to put what we know in this upper left hand corner here. We're going to make sure that our units cross out right here, so we know that we've got grams and grams. You always ask yourself, can you go from grams to kilograms? You can. You know that 1 kilogram equals 1,000 grams. So now in this case, you would use algebra and cross those grams out. You're left in kilograms. And then you know here you're going to multiply 8,200 by 1. And obviously you don't need to do that in your calculator, but I'm just trying to teach you good practice and good steps. And then you would divide by 1,000 and you would get 8.2 kilograms. Alright, so I'm going to stop the video here. You guys are going to practice, and the next video that I'm going to make will start with explaining how these are done.